Alright guys, so today we are going to continue our chapter. We're getting towards the end of the chapter actually. It's over exponential growth. This exponential and logarithmic chapter we've been in for a while. Now that we've seen most, if not all, of the content in the chapter, we're actually going to move on to one of the last sections, which is the word problems. Okay? And we're going to dive in and see, all right, so how do we take what we've learned the last few weeks and actually turn this into real world things that people have to actually do in their jobs? So I've come up with quite a few word problems if you look at the sheet I handed you, and you can see what we're going to be looking at today. Now, if you go back and remember the beginning of the chapter, we learned that for most exponential equations, they come in the form y equals a times b raised to the x power. Okay? You guys remember that, hopefully? And not only do we have that equation, but we also know what these variables stand for. Okay? We've got a, we've got b, we've got x, and we've got y. Now the first variable that I want to talk about is a. A is the starting amount or the initial, okay? If you've ever taken a business class, you'll think of the word principal, okay? The starting amount. Right. And B is going to represent either our growth rate or our decay rate, okay? So in some of these word problems we look at, we're either going to be growing or we could be decreasing. Populations in the world, they go up, they go down. They're modeled based off of these exponential growth and decay functions. Now, X represents your time. Sometimes that's in years. Sometimes that's in days, months, seconds. If you've ever thought about a biology class and thought about bacteria, that's usually for per second or per minute. And then Y is going to be your ending amount. So if you think about some of these word problems that we're dealing with, we're going to have an amount that we started with. We're either going to get bigger by growing or we're going to decrease, we're going to decay. So let's go ahead and dive in now that we have the equation and what all the variables stand for. Right? Let's look at it. The world population in 2000 was approximately 6.08 billion. The annual rate of increase was about 1.26%. Find the growth factor for the world population. All right? So they're asking for the growth factor, which that's going to equate back up to that variable b. Now, if you think back to the beginning of the chapter, we know that b represents 1 plus or minus the percentage. Okay? 1 plus or minus the percentage. Now, in these word problems, we can't actually use the percentage. We can't do 1 plus 1.26 because we have to have a decimal instead of a percent. So first of all, we have to figure out, is this growing or is this decreasing? Is it decaying? Well, it says right there in the problem that it's growing. Okay, and also in the original problem, it says the word increase. So we know this is going to be 1 plus, okay? And then our job is to decide, is this 1.26%, what is that as a decimal? Okay. We spent a lot of time reviewing this. We know that to convert a percent to a decimal, we have to move the decimal place 2 places to the left. Okay, so the decimal place is now going to be here. And then we have to put in a 0 where it needs to go. So to find the growth factor for the world population, we actually have 1 plus 0.0126, which comes out to be 1.0126. So the growth factor for this world population problem is 1.0126. That's what we're going to put in for the variable b. Now let's look at the second part of the problem. Suppose the rate of increase continues to be 1.26%. Write a function to model the world population. So they're asking us to take this original function and substitute in everything we know variable-wise. Okay, so let's look at it. Suppose the rate of increase continues to be 1.26%, write a function to model. So we don't know what we're ending with because we don't have a time involved yet. And if you look at part C of the equation, that's where time is going to come into play. All right? So we don't know what the ending amount is yet. We do know how many people we started with. What did we start with? Okay, it says there right in the problem that originally the starting amount was 6.08 billion. Okay, we're going to leave it at 6.08. Our answer is going to be in terms of billions. Parentheses. Okay. Now that we know what the growth rate is, that's what we computed in part A, we can go ahead and substitute that in for the variable B. And since we don't have anything to do with time yet, we don't know what the variable x stands for, therefore we're just going to leave that as a variable. So we actually still have two variables in this problem. All right? Let's go ahead and look at part C while we're at it. Let x be the number of years past the year 2000. Find the world population in 2010. Okay? Let's go ahead and underline that because that's the most important part of this question that we have in part C. So we want to think about, we have this equation. The problem wants to know what the world population is after a certain amount of time. So that means we're solving for the variable y because we want the ending amount. All right? Now what we need to decide is how do we go from part B to part C? We have the 6.08, we have the growth rate, the growth factor. Now we need to figure out what number should we put in here for x. Now be careful, it's not 2010, so don't go ahead and start writing 2010 up there. I've seen a lot of people do that lately. Okay? Look at what the problem really wants to know. Let x be the number of years past the year 2000. So we're actually going to have to do a little computation before we can even substitute in a number for x. We want to know that 2010 minus the year 2000 means that there have been 10 years that have elapsed that we're trying to calculate for. So the number that we actually put in for x is not 2010, it's just 10. All right? And now that we only have one variable, we can actually go ahead and compute our final answer for this problem for part C. Okay, we're going to grab our calculators. We're going to type in exactly what we see, parentheses and exponents included. So let's go ahead and dive in and do that. 6.08, parentheses, 1.0126, raised to the, so we're going to use the caret button, raised to the 10th power. All right. Now 6.891. Now what in the world does that mean in the context of the problem? Let's go ahead and write it, but then we're going to have to try to decipher what our answer really is in the context of the problem. So 6.89, right? Anybody have any thoughts? Yeah, okay, so after 10 years, the population has grown from 6.08 billion to 6.89 billion. Okay? That's a pretty big jump, even though it's only going up 1% roughly per year. So we went from a little over 6 to we're getting close to 7 billion in just 10 years. All right? Think about that.